In 2026, a single keystroke triggers the deployment of thousands of validated code. Typing syntax is now a legacy skill. Standard autocomplete now acts as a junior developer who hasn't read your documentation. These models often see the file you are editing, while remaining blind to the utility libraries and custom interfaces you wrote years ago. As implementation becomes automated, the engineer's focus moves to the system blueprint. We are seeing the rise of the AI architect, a role defined by directing models rather than writing functions. 2 years ago, the primary bottleneck for shipping software was human typing speed. Today, the constraint is the speed at which a human can verify AI output. The volume of code an engineer produces is no longer a primary performance metric. Strategic value now resides in the ability to orchestrate context across a sprawling repository. Shipping velocity is often an illusion. Without careful oversight, AI-generated code drifts away from the original architectural vision over time, creating a fractured code base that is difficult to maintain. Unmonitored agents frequently introduce subtle security flaws or hallucinate non-existent dependencies. They generate code that runs in standard environments but fails in edge cases the model did not foresee. To manage this, teams are moving toward automated governance. These systems act as a mandatory reviewer in the pull request pipeline, scanning every diff for vulnerabilities before a human is involved. Raw coding speed without automated governance creates technical debt at scale. If the verification layer is missing, AI generation can actively impede long-term product growth. In 2026, the market is defined by two dominant architectural approaches, the Cursor IDE and GitHub Copilot. Their performance is measured against SWE-bench verified, the standard for evaluating how effectively an agent can solve real-world GitHub issues. This chart shows the $10 Copilot plugin solving 56% of tasks, averaging 90 seconds. The $20 Cursor IDE scores lower on accuracy, but finishes in 63 seconds. A paradox: the cheaper tool is more accurate, but the expensive tool is 30% faster. This discrepancy is not a result of the underlying models. It is a direct reflection of how each product handles context and execution. The choice between these platforms is a decision between synchronous, in-editor speed, and asynchronous, ecosystem-integrated reliability. Cursor is a standalone VS Code fork. To use it, you must abandon your existing editor for an environment built specifically for AI integration. This allows for the Composer feature, which moves beyond simple completion to act as a project-wide editing agent. When assigned a task, Cursor spawns async subagents that work on nested subtasks simultaneously. A single prompt triggers coordinated work across the entire project. The editor manipulates dozens of files simultaneously, allowing for massive refactors in real time. Cursor also utilizes cloud agents in isolated virtual machines. These agents build software and use a browser to navigate the UI, providing video proof that their changes work as intended. Because it controls the IDE, Cursor builds deep semantic indices of the codebase. Teammates share these indices, allowing new engineers to query a massive monorepo in seconds. This environment supports flexibility between frontier models like GPT-5 and Claude, and even allows users to bring their own API keys to bypass usage limits. The editor is further extended by a marketplace for plugins that bundles specialized skills and MCP servers directly into the interface. Cursor provides a low-latency, synchronous environment.
It is designed for multi-file refactors, where the developer requires immediate, project-wide context. GitHub Copilot takes an asynchronous approach. Instead of a standalone IDE, it exists as a plugin for VS Code, JetBrains, and NeoVim. Its workflow is designed for delegation. You assign a task and move on, while the system handles the execution in the background. A GitHub issue can trigger a coding agent inside a remote actions VM. The agent clones the repository, configures the environment, and makes changes autonomously. Developers can assign multiple models to a single issue simultaneously. This allows a team to compare independent pull requests from Claude, Codex, and Copilot for the same problem. Unlike Cursor's live editor diffs, Copilot generates secure draft pull requests. This integrates the AI directly into the existing project management pipeline.
This extension-based model is the only option for teams that require specialized environments like Xcode, Visual Studio, or the JetBrains suite. Copilot prioritizes a reliable, asynchronous pipeline over instantaneous in-editor speed, making it a primary choice for large-scale team coordination. At the enterprise level, security and compliance are often more important than the speed of individual features. Copilot leverages GitHub's existing enterprise infrastructure, offering SOC 2 compliance, pooled usage credits, and strict code tracking APIs. Cursor's enterprise offering is growing, but it currently lacks the native integration with GitHub Enterprise Server that many massive organizations require. Large engineering organizations require these strict, auditable pipelines to maintain system integrity. They demand that AI tools fit into existing security and administrative workflows. A tool's viability in a corporate environment is determined by its audit logs and governance, not its autocomplete latency. Implementing these tools requires a change in how engineering leaders manage their teams. The primary daily action of a senior engineer is now context orchestration. Before executing a task, the engineer must feed the agent specific architectural patterns and custom rules to guide the model's logic. They perform strategic translation, converting broad business goals into atomic technical tasks that an AI agent can execute. Once the code is produced, AI review tools scan the logic. They find the subtle errors and insecure dependencies that can slip past human reviewers in a high-velocity environment. The engineer acts as the editor-in-chief. They filter the massive stream of AI-generated logic to ensure only high-quality, secure code enters the main branch. Auditing AI logic has become the most critical skill in software development. If an engineer cannot verify code faster than the machine writes it, they become a bottleneck. Choose Cursor for complex, multi-file editing, model flexibility, and deep indexing of monorepos. Choose Copilot for budget-conscious teams, strict enterprise compliance, and workflows centered around GitHub issues. Many power users now layer both, using Copilot for fast inline speed and Cursor for heavy autonomous refactoring. For technical leaders, the cost of a poor architectural bet is high. Unleashing AI agents without the proper infrastructure can create a maintainability crisis. Transition your team in phases. Begin with stabilization through basic tools, implement strict governance, and then move your senior talent into full orchestration roles. The engineering teams that succeed in 2026 are not the ones that type the fastest. They are the ones that successfully govern and orchestrate the agents. Stop coding, start architecting.